All right, here we go. 13.5. We're going to do law of cosines. And click that on here. So, yeah, that writes a lot better. So it's law of cosines. Let me write down what the law of cosines is first. And let's figure out why we need it, why we want to use it, and all that kind of stuff. So hopefully this will come back to you a little bit. Let me just write it down. C squared equals a squared plus b squared. You say, wait a minute, that's not law of cosines. What is that? That's Pythagorean theorem. Well, the law of cosines looks very similar. It starts off anyway looking just like the Pythagorean theorem. That's right. Do you remember that from last year? Minus 2ab cosine of angle C. That's a larger C than this C. The lowercase c's represent what on the triangle? The sides on the triangle. And of course the uppercase, the capital letters, represent the angle. Good. Brandon, you getting all this down? Okay, not a very good view with your face in the book. Okay. All right. Well, why do you have your head down on the ground?
I'm embarrassed.
Oh, I keep hitting the wrong button. All right, so let's do this one right here.
Brandon, are you embarrassed?
All right, guys, please. There we go. All right, here's a triangle, and I purposely picked one that's a non-right triangle because the reason that we want to pick a non-right triangle is because that's the whole reason why we want to learn the law of cosines. And Monday we're going to learn the law of sines. Okay. We learned a way to solve for missing angles and sides with a right triangle. What did we use? What are a couple of things that we used to find missing sides and angles with a right triangle? Pythagorean theorem is one, so if you know two sides, you can always find the other one, right? Now, the Pythagorean theorem didn't help us find any angles, though, did it? But what helped us find angles? Sine, cosine, and tangent, exactly, okay? And if you only knew one angle and one side, you couldn't use Pythagorean theorem, so you got to go to a trig function, sine, cosine, tangent, okay? But if you have a non-right triangle, then you're not able to do this. I'm not going to go through the proof to show you why this is the way it is, and I'm sorry, I know you're dying, and they don't even do that in the book. And in fact, I don't even know if I know where to start on this one, but I think online I've seen a couple people prove this thing. I know that on law of sines is actually kind of easy to prove, and I looked at one of his things for law of sines, and he actually does it. He actually proves the law of sines and how you develop the equation. All right. So I don't know if I'll do that in class or not for you, but if you want to look on Khan Academy, feel free. He does a good job of explaining it. Makes sense. And there's other guys that do it as well. All right. Let's talk about this. What if we said this was C, and this was A, and this was B? All right. And let me take. Now watch this. We said this capital C is an angle, isn't it? Well, which angle is it? This is how we just need a method. We need to stay on the same page, right? Steve? Yeah, it's opposite or across from, if you want to think of it that way. It's opposite side C. So this would be angle C. Make it a little bit bigger, okay? This is side B, so the angle B would be across from it or opposite side B, and that would be angle B. This is side A, so across or opposite would be angle A. So that fits with this thing right here, doesn't it? If you look in the book, they actually write the law of cosines as 3 different ways. I think that's, to me personally, I just think that's kind of a waste of time because you can always just use the one way. What's that? That's right. You can, C doesn't have to be this C right here. C could be any of the sides, and these two are just the other 2 sides. Does that make sense? So I just learned one way and just generalize it. This side is opposite this angle right here. It doesn't matter if it's A, B, or C, or X, Y, and Z, right? It could be any letters at all. This is just a general form to represent. These are just the other 2 sides other than C. Got it? So if you know this side and this angle, they're the ones going to be opposite to each other. And you don't even have to know either one of them. But anyway, let's just keep going. Let's put some numbers in here. And I'm just going to take the numbers from the books. Let's say this is 36 degrees. Let's say side A is 7. So we'll say that. That's supposed to be an equal sign. Doesn't look like one, but it is. All right, and we don't know what side B is. And side C is 5. All right. So these aren't special triangles because they're not right triangles. The only special triangles that we know of are right triangles, aren't they? So we have to go about and do this. This is set up perfectly for us to use the law of cosines. You just plug and chug, basically. All right, we have one more example after this to find the angle. The angle's a little bit more difficult, but you can still do it. Now watch what we do. Remember, this side is opposite this angle. So what do we know? We only know one angle, don't we? So I'm using this angle right here. So this is kind of be like our C. All right, so we're going to take the cosine of this angle. So where is the B? The B now is out here by itself. So I take this side, put that by itself. So B squared equals, you follow me on this? How did I know to pick that one? Because that's the angle that I know. All right, so we pick the side opposite the angle to go on the ends right here. Right, so I know this angle, so the side is going to be this one right here. That's the side out there by itself. What's that? Oh, we're solving for everything. Let's solve for side B right now. Okay, so let's solve for side B right now, because yeah, that's the easiest thing to solve for, because it's perfectly set up for us to use the law of cosines. So we're going to solve for side B. We know that angle, so we're going to put that right here. Well, what goes right here and here? The 5 and the 7, the other two sides. Do you see that? So this is going to be your A and B. And again, it's hard to anyway, it's the other two sides. All right, this is the side we're solving for. These are the other. I was going to say something, but I wasn't. All right, so this is the side opposite this angle. That's the thing that's going to go by itself. Now these two right here are just the other two sides. So what do? 5 squared plus 7 squared minus 2. And then watch. What goes here and here? Well, just these two sides, right? So we just put a... Yeah. Yeah, I just made it. I made it look a little bit better. It's 5 squared plus 7 squared minus 2 AB, or 5 times 7. Now, what do we put now after that? Cosine of the angle that's opposite this side right here, which is what? 36 degrees. All right? This angle is opposite this side. That always has to be true. All right? So whatever this angle is, this side has to be opposite this angle right here. Sometimes we know the angle, sometimes we don't know the angle. All right? If we didn't know the angle, then you would know this side. All right, we'll do that in the next example. You'll see what I'm talking about. So now what we do is we just plug and chug into a calculator and get an answer. Now that's not for some people it's not as easy as it looks. Some people have a little bit of trouble using a calculator on this. Here's a hint. Now, this b squared equals all this stuff. So what are you going to have to do to get b by itself? Square root. Okay, so depending on your calculator, again, different calculators do things different ways. So some of your calculators, when you put everything in exactly the way it is, you're going to have to put a big square root first. Okay, so I would put a square root, then a parentheses. Then you can put all this stuff in. Now, here's another place where you want to put a parentheses. This is important. See where you're subtracting all this stuff right here? You're going to need a parentheses right there. And then we'll close it. So you need to actually put in your calculator parentheses at those two spots. Does that make sense? Okay? So again, depends on your calculator. If you have a graphing calculator, you start with square root, and then I would put a parentheses. Okay? And then I would close the parentheses like that. So if you use a graphing calculator, I'm going square root, then parentheses, then you can put everything in just the way it sits right there. All right? You hit enter at the end, and you should come up with the answer.
I got 4.167.
Yeah, and they rounded to the 10th, so what would it be? 4.2, right. So put it in a calculator, and you should get 4.2. This is something that you need to practice. Don't just think, oh, I can use a calculator, no big deal. Okay, this is something people get messed up on every once in a while, so please practice it and make sure that you know what you're doing here. Yes, sir?
You keep the minus inside the...
No.
Just put it in.
If you're using graphic calculator? Okay.
You don't even have to put all those other parentheses. Well, like after 7
You don't need this parentheses right here?
Yeah, I put it in as, I just put the square root and then...
Okay, it may work without all those things, but I'm just trying to logically group things together and trying to think of how the calculator would think on this. I know if you just have one of those, one of those basic scientific calculators, you do need a parentheses right here and right here. All right, so if you have a basic scientific calculator, I would go 5 squared plus 7 squared minus parentheses, okay, 2 times 5 times 7 times 36 cosine. Close the parentheses, hit equals, and then you're not done yet. What do you do after you hit equals? You got to square root it, okay, because we didn't square root from the beginning. So if you have a regular basic scientific calculator, you need to do it that way. All right. Now the only thing I have on this computer is a graphing calculator, so let's do that. All right, let's punch this in So I'm going to hit square root, second function, that. Then it puts a parentheses, and I hit 5 squared plus 7 squared minus, and we don't need a parentheses on this calculator, so we go 2 times 5 times 7 cosine of 36. We do need to close that with a 36, and I hit enter, and then boom, there it is, 4.16. We ran it to 4.2, and that's your answer. All right, let's go on to the next one.
Yeah.